Okay, so guys, 5.3 is basically it says normal distributions, finding values. Okay, so guys, before when we had the z values, we were able to find the probabilities, right? So when we said what's the probability that z is less than, I don't know, negative 0.25, we would go to the table, we would look for negative 0.25, we would find that number, and that's the probability. What we're doing now in this section is we're going backwards. We're going to find the z-scores if we have the probability, okay? So I want you to notice what it says here. It says find the z-score that corresponds to a cumulative area of 0.4761. So the first thing I'm going to do, guys, I'm going to grab my chart. Oops, that's not my chart. There we go. Here's my chart. And I'm going to zoom in just a little bit. And this is what we're going to do. We're going to look for that number. So come back here. We're looking for 0.4761, okay? So guys, I'm going to look at my chart. I'm probably going to have to go to the other page, 4761. Do you see 4761 here? Right down here at the bottom, right? So the first thing I'm going to do, does it let me type in? Yeah, it does. Let's go 175. Okay, 4761 was down there at the bottom, so it's negative 0.0 what? 0.06, right? So guys, I'm going to come back over here, and we're going to say, well, our z value is negative 0.06. Does that make sense how we're able to do that using the table? Fred, we're good? Okay. So now look at the next one here. It says, let's find a z-score that corresponds to a cumulative area of 0.05. So I'm going to come back over here, 0.05. Okay, so guys, look. Oh, 0.05, 0.05. Is it kind of between these two numbers? 0.05, right? If I come back over here, guys? But remember what I'm looking for. So it's telling me that the area is going to be 0.05, right? So I'm going to look at my table here, and I'm going to say, where do I find a 0.05? So a 0.05, oh, here we go. No, that's 0.00. So I got to go 0.05. Okay. Do you agree that maybe between these two numbers would be a 0.05, right? So if this is negative 1.6, this would be negative 1.6. Let me come back up a little bit so I can see what it is. Negative 1.6, what, 5? And isn't this negative 1.64? So I'm looking for the number that's between those two. What do you think is between negative 1.65 and negative 1.64? 1.645, right? So right here, guys, I'm going to come back over here. Z is equal to negative 1.645, right? So look, all I'm doing, guys, I'm looking at my picture, right? Look at what the Z value is telling me. It's telling me that my area is what number? What's the area right here? 0.05. Go to your chart. Wouldn't you say that 0.05 should be somewhere right about here? Everybody agree? 0.05. Think about it this way. How much is 0.05, Andres, in terms of money? 0.05. I gave you 0.05 of a dollar. How much money did I give you? 5 cents, right? So think about this in terms of money. We're looking for 5 cents, right? How much, think about it this way, forget about the 95. How much money is that right there? That's 4 cents. This is 5 cents, but it's a little bit what? It's a little bit more, isn't it? I'm looking for exactly 5 cents. Well, if this is 0.495 and that's 0.4 or 0.505, wouldn't a nickel be right here in the middle? Okay. What's my z value? Negative 1.6. This is negative 1.65. This is negative 1.64. So wouldn't the middle be negative 1.645? That's all I'm doing, right? I'm just looking at my picture, right? So guys, look, let's do another one. Let's see if we can figure this out. Okay. So guys, I want you to notice something. The difference between number 1, number 2, and and number 3. Okay, look at the way number 3 is written. It's given to me as a what? Percent. How would I write that as a decimal? There you go, right? So the area is 0.1271. So again, the first thing I'm going to do, I'm going to come back to my chart. I'm going to look for 0.1271. 0.1271, 0.1271, right? Okay, here we go. Oh, look, right here, isn't this it? Okay, so negative 1 point what? Negative 1.14? Okay, cool. So here, Z is equal to negative 1.14. Okay, so guys, those of you who like the chart, right? We can go there, we can look for it. What did we end up doing with number 2? Because we could not find exactly 0.05, but we found the 2 numbers in the middle, so then didn't we basically find the average of where those 2 numbers would have been? Okay, now guys, there's a way that you can do this on the calculator as well. So I'm going to show you how to do this on the calculator again. Yeah, right? Okay, but guys, remember, I want to please everybody, so I'm going to show you both ways, right? So I'm going to show you on the calculator as well. Okay, so look, right? Okay, so think about it this way, guys. A little while ago, when we were finding our probabilities, what was the function that we were using? We were coming to second bars, and we were using which one? The normal CDF, right? So we were using the normal, right? Okay. What we're doing now, guys, is we're kind of going backwards. We know what the probability is. We want to go back and say, hey, could we figure out what was the Z value that told us that? We're going to use something called the inverse norm. The inverse is taking us back to where we started with, okay? So I'm going to come down here, to inverse norm, and I'm going to hit enter, okay? Guys, I'm going to come to our first problem. What was the area that we knew in the very first problem? So let's type in 0.4761, close it, enter it. Okay, guys, if we round to 2 decimal places, because the Z values have 2 decimal places, would we put negative 0.05 or negative 0.6? Is that what we got? Oh, watch out. Negative 0.6, right? Right? Don't we have right here, Fred, if I look right here, isn't there a 0.06? Right here, look where I'm doing my cursor on the screen. 0.06, right? Isn't that 0.06 right there? Now if I look right here, go to 2 decimal places. Would you leave that 5 alone, or would you round it to a 6? There you go. Same thing, right? Okay. So guys, if I want to do this again for the next one, right? I'm going to come back here. Second bars. We're going to now go to which one? Inverse norm, right? Because we're going backwards. What's the number we're going to type in? 0.05 or 0.05, whatever you want to put, right? Close it off. Hit enter. Are we coming up with negative 1.60? Oops. Yeah, negative 1.64. We went to 3 here because we weren't exact. So, because we're using the tables, didn't we come up with still the same answer? Right? Okay. So let's. So I'll put it this way, guys. On the test, I'm cool if we put 2 decimal places for these. You got an error? Okay. So look, let's do it again. So Fred, I want you to notice what I'm typing in. So look, let's clear it out. Right? We're gonna go second bars. Okay. Remember, we're gonna go inverse norm. We're gonna go inverse norm. Okay. Fred, the number you're typing in is the area. So look at the area that it gave me, 0.05, right? So type in point. Oops. 0.05. Why is it locked? Unlock all buttons. There we go. 0.05. Close it off. And do we get the same thing? Same dealio, right? How is your calculator coming up?
Comes out to the screen, same screen as before hitting that.
Uh-huh.
Then it takes you to the screen to do the area, then the mu, then the deviation.
Okay, what's the mu number? 0. And the deviation is? Same thing. So you're just typing in that number and then just scroll down and hit paste, right?
I just didn't hit enter.
Yeah.
AI.
Same thing? Okay, let's do one more, guys, just to make sure that we're on the same page here. Inverse norm, right? And what number am I going to enter in this time, guys? 0.1271. Thank you so much. 71. And close it off. And hit enter. And are we still coming up with negative 1.14? There we go. Okay. So again, guys, you have options. If you like the table, hey, use the table. The table on this one is going to take you a little bit longer to do because you're looking at a whole bunch of numbers there, right? And then you're trying to figure out, yes, and it can get a little confusing, right? So guys, if you are a big fan of using the table when you have the z-values and you're trying to find the area, that's fine. But again, I don't want to tell you that using the table is wrong. It's just you guys really got to pay attention to where you're going. And because there's so many numbers there, I want to make sure that you're doing okay, right? So now let's take a look at the next problem here, guys, and let's see if we can figure this out. So the first thing I'm going to do here, guys, I'm actually going to draw a picture, okay? So here's my picture, okay? And here's my 0, 1, 2, 3, right? Negative 1, negative 2, negative 3, right? Those are my standard deviations. Look what it's asking us for. It says, let's find a z-score for which 75% of the distribution's area lies between z and negative z. Okay, so let's see if we can figure out what that even means. They're saying that 75% of the area is going to lie between two numbers that are the same, except one of them is what? Positive, and the other one is what? Negative, okay? So guys, think about it this way. I don't know exactly where this number is going to be. I'm going to cut one here, and I'm going to cut one here, and I'm going to say, look, it's telling me that this area here, bless you, it's telling me that this area here in the red is going to be 75%. Isn't that saying the same thing as that area there is going to be 0.75? Does that make sense? Okay, so guys, we know that that area in the middle, because it tells me, how do I know it's in the middle? Because the word of what? Between, right? Okay. So let's think about it this way. Guys, if there's 75% in the middle, what percent would be left for these two pieces? 25%, right? Because the whole area has to be what? 100%? Okay, so we know that those two pieces have to be 25%. But because this graph is symmetric, couldn't I take 25.25, because that's 25%, divided by 2, that would give me 12.5% or 0.125. So we know that this here is going to be 0.125. And wouldn't this area here also be 0.125? Okay. So guys, what I'm going to do now is I'm going to figure out, okay, could I find a z-score that tells me that the area to the left here in this blue piece is going to be 0.125. Yeah, we can. We can go use our calculator, and we're going to come back here, and we're going to go inverse norm. Okay? And we want that area in the blue to be what percent again? Or what number? 0.125, right? And then I'm going to hit enter. So guys, to 2 decimal places, what value am I getting for z? Negative 1 point what? 15? Okay. So that's telling me that this number here is negative 1.15. And then wouldn't this one here, guys? I know my graph isn't pretty because I'm drawing it after 2. So this one here is negative 1.15, and this one here is positive 1.15, right? And my zero's in the middle, right? And guys, do you see that I don't really even have to do the calculation here, because once I do this calculation, it's telling me the other one's going to be the same, because that graph is what? Symmetric, right? It's whatever's on this side will be the same thing on that side over there. Does that make sense? No? Okay, so think about it this way. So, Rafael, remember what we're doing? Are you okay how I came up with a negative 1.15? Did I lose you? Okay. So what I'm saying is, we know that the area in the middle, was going to be 0.75, right? Because it was 75%. So if the whole thing is 100% and the middle is 75%, wouldn't that tell me that the rest of it would have to be 25%? Okay, so he said, look, if the whole of those two pieces have to add up to 25%, let's take 25 and divide them by 2. That's how I came up with the 0.125, right? And the 0.125 over here, because those two numbers together add up to 25%, right?
And then what threw me off is.
Hold on, let me finish with Ralph, and I'll come back to you. Just because I want to make sure that we're good here. So then I'm saying, look, if I know that this area over here in the blue outline is 0.25, what's my z-score? So if I go inverse norm of 0.125, it'll tell me what that z-score is, right? So it's telling me that if I have a z-score of negative 1.15, the area to the left of it would have been 0.125, right? But because the graph is symmetric, meaning this is kind of like a mirror. Whatever I have on this side, I have on that side. Well, if this is negative 1.15, positive 1.15. I'm sorry, Fred, I didn't mean to cut you off.
It was just what threw me off between the z and the z, like, we're assuming z is what, infinite?
No. It's asking you, can you tell me what the z-scores are? So that in between them, the area is 75%, right? So what are those two z-scores
Like,
going to
we
be?
have 75%.
In the middle, what are those boundaries going to be, right? So it's telling me, okay, the middle is 75%. What are the two boundaries that give me that 75%, right? Okay, so hold on, I'll be right there with you. So guys, all right, good question. Let's make sure, whoa, where'd it go? Okay, let's make sure that we understand what they're asking us to find. They're telling me, let's find the z-scores. Okay, we're looking for the two numbers here. So that 75% is where? Between them. So what I'm saying is, here's our picture, right? Here's our lump. Okay, we know that in the middle, that area is going to be what percent again? 75% or 0.75. We're looking for those two boundaries. Well, the way we find those two boundaries is you say, well, we know that 25% is left over, then 12.5% is going to be here, and 12.5% is going to be over there on the right. So if we know that the area here on my left, in the blue, is 0.125, what would have my z-score been? So when I go inverse norm, it tells me, hey, your z-score would have been negative 1.15. Well, if this one is a negative 1.15, then the other one has to be automatically a what? A positive 1.15, right? So what are my two z-scores? Negative 1.15 and positive 1.15. Good. Okay. Good questions, guys. Let's take a look-see here at the next one. Okay. So look what it says. It says find the z-score that corresponds to each percentile. Okay, so guys, first thing I'm going to do, this is the 8th percentile, right? Okay, the 8th percentile. Remember what the 8th percentile means? It means we did better than what? 8% of the people, okay? So let's think about it this way, right? 8th percentile, right here. Tell me that this area here, wouldn't that area right there be 0.08? Because we did better than 8% of the people. So we're really us. Yeah. I should use a different color here. All right, so give me one quick second. Let me just make sure that I'm doing this the right way, because sometimes I forget myself. If it's 8%, that's telling me that the area, oops, did the wrong one. It's telling me that the area to the left here is 8%. I'm looking for the z-score, where the area to the left is 8%, right? So guys, remember what I'm going to do again? Inverse norm, right? I'm just going to come back over here. We're going to go second bars. We're going to go to inverse norm. And we're going to type in what number? 0.08, right? Okay. And we're going to hit enter. And look what number we're coming up with. Negative 1.40 what? Negative 1.41, good. So z equals negative 1.41. Guys, I want you to think in general, right? I want you to think about it in general. So if I were to do this right here, y'all agree with me here that my z-score is 0? Okay, what's the area in this red part right here? 50%, isn't that 0.5? And isn't the area here also 0.5? Look at the area that we're looking at, 0.08. Isn't that going to be like, man, that's going to be way over here to the left, right? So remember, when I'm going this way, aren't my z-values negative over here? Because my z-values here are like +1, +2, +3, -1, -2, -3. So when we come up with a negative, something like negative 1.41, that tells me, hey, we're probably doing this the right way, right? We're coming up with an answer that would make sense, right? Okay, guys, how do you think we're going to do this for the 25th percentile? The same way, right? So we're going to figure out, what we're saying is it's going to be the 25th percentile. So let's come back over here. Let's grab our calculator. We're going to go inverse norm, but now we're going to type in point what? 0.25. So 25. Close that off. Negative, right? So my z value again is negative 0.67. Guys, look at the area that we're looking at. We're looking at 25%. So isn't 25% roughly half of, if that's 50%, 25% would have been half of that area, right? So I'm still in the negative range, okay? And then the last one is the what percentile? The 95th. Guys, if this whole thing is, if the area of everything here is 1, we're now looking at 95% of that area, right? So shouldn't my z value be a positive number? Because I'm looking at all of this area over here. So again, we're going to come back. We're going to go second inverse norm, right? We'll get that inverse norm, but now we're going to type in what number again? 95, right? So let's go 95. Boom. Let's hit enter. 1.60, what? 64? Yeah, 1.64, right? Boom. And then you got it. Okay. For the P95, that's right. So what I'm trying to do here we go, is, here we go. So for our 8th percentile, we got a z-score of negative 1.41. For a 25th percentile, we got a negative 0.67. And for our 95th percentile, we got a 1.64. Okay. So, oops, let's take a look-see at the next part here, guys. Okay, so what we're going to do now, guys, remember before when we had our x values and we were transferring them to z-scores so we could find our probabilities? Now we're going to go backwards. We're going to say if we have the z-score and we know what the mean is and we know what the standard deviation is, could we find the original x value that we had? Okay, so let's take a look here. It's just doing, yeah, it's, these are gonna, guys, the calculation part is gonna be easy. The part that we really gotta figure out is, what does this really mean? Okay, so let's take a look at problem number 6. Yeah, they're gonna be in order, but again, I wanna make sure that we actually know what we're looking at here. So let's take a look. It says, we have a vet. The vet has records of dogs, right? The weights are normally distributed with a mean of 52 pounds, standard deviation of 15 pounds. Find the weights x corresponding to the z-scores of negative 2.33, positive 3.10, and 0. Okay, so we're actually going to do this 3 times, okay, guys? So look, I'm going to do it like this. I'm going to just call it z1 because it's my first z-score, okay? And the first z-score we have is a negative 2.33? Okay, we're going to find the first x value. I'm just going to call it x1 just because I got to do this 3 times. I want to at least kind of be consistent, right? Here's my formula right here, guys. So first question for number 6. What is our mean? 52. Okay. What's our standard deviation? 15. Okay. So now let's take a look. The first thing I'm going to do, guys, it says let's write down the number mu, which in this case was 52, plus, we're going to take the z-value. What was the z-value we have in the first case? Negative what? Very good. Negative 2.33 times what number? Times 15, right? Times the standard deviation. Okay. So guys, I want you to think about, man, do you remember the first day of school and we did stuff like order of operations? What should I be doing first? Parentheses. Okay, so let me grab my calculator real quick. Let me clear this business out. Let's take negative 2.33 times 15 equals, and then we're going to add how much? 52 to it, right? Okay. Gonna hit equals. So how much, that number 17.05, what number is that even telling me? What are we looking for here? Okay, but what does X stand for? I'll give you a hint. We circled it in the problem. The weights of the what? Of the dogs. Okay, so very good for the first dog. Okay, so the first dog weighed in at how many pounds was it? 15 point something though, right? Or 17.05. Okay, so the first dog weighs in at 17.05 pounds. Okay, let me ask you a question. What was the average weight of the dog? Do we know? What's the average weight of the dogs that they looked at? 52 pounds. Was that dog underweight? Wasn't that dog underweight? It's a small dog, right? The average weight of the dogs that they looked at was 52 pounds. This dog only weighs how much? 17. Guys, because that dog is underweight. Under, the z-score is what kind of number? Negative, right? Because he's smaller than the average. Does that make sense? Okay. Now, let's do the same thing again, but we're going to do it the second time. The second time, our z-score was what? 3.10? Okay. So now we're going to find our second x value. We're going to do it the same way. We're going to take 52 plus 3.10 times 15. Okay. So let's take our calculator. Let's take 3.10 times 15 plus 52. 98.5. So the second dog weighed in at 98 pounds exactly. Was it 98 exactly? 0.5? Guys, is that dog, wouldn't we say that dog has a greater weight than the average? Because the average is only 52. This dog weighs almost how much? Almost twice the amount, right? Okay. All right. So now let's do the third one. What's the third one? The z-value is what number? 0. Okay. So we're going to go like this. X3 equals 52 plus 0 times 15. Wouldn't that still be what number? 52? Very good. So that's telling me that the third dog is actually right at the average weight of all the dogs that we're looking at. Right, are we good? Yeah?
I think this part is easier to work.
So think about what we were doing before. What we were doing before was, if I told you, hey, Fred, I have a dog that weighs 98.5 pounds, right? And the average weight of the dogs we're looking at is 52 pounds with a standard deviation of 15. What was the probability that dog what's the probability that I pick a dog that weighs 98 pounds, right? So we would say, okay, well, look, let's take that 98 and let's convert it to a z-score. Well, the z-score would have been the number, for a 98-pound dog, the z-score would have been the number 3.10, and then we would find a probability that the dog that we picked weighs 98 pounds, we could say or less, or we could say let's find the probability that a dog weighs 98 pounds or more, right? That's right, whichever way we're looking at, right? Here, we're just going backwards. Good? Cool. Okay, so guys, let's take a look at the next part here and see if we can't figure out what we're supposed to do. Yeah, so hold on, let me just There we go. Okay, so look what it says here, guys. In a survey of men ages 20 to 29 in the United States, the mean height was 69.4 inches with a standard deviation of 2.9. What height represents the 90th percentile? Okay, so guys, remember what the 90th percentile is? If we're doing this, we're going to find the z-score that corresponds to the 90th percentile. If I come back to my notes that we were looking at a little while ago, but hold on, wait. I want you to slow down a little bit. See how we did these problems right here? When we said, if we have the 8th percentile, my z-score is negative 1.41. If we have the 25th percentile, we're looking at 0.67. If we have the 90th percentile, we're finding the z-score to be 1.64. So what we need to do here, guys, for this next problem, do we know what the z-score is right now? No. So let's find the z-score that corresponds to the 90th percentile. Do y'all remember how we did that? We went, what, inverse norm? Right? We went down to inverse norm, hit enter, and then we typed in what number? 0.90? 0.9, 0.90, it's the same thing. Guys, what number would I get for my z? 1.28. Okay, so all this is telling me is that right here, my z value is going to be 1.28. Okay? All right, so look what we're trying to find now. It says we're looking for the actual height. So guys, what we're going to do is we're going to say, okay, well look, if my z-score is 1.28, what would my x-score be, right? What would the height actually be? So remember how we did this problem a little while ago with the dogs? Remember we did, we said, look, let's take the average, which is the mean. In this case here, guys, what is our mean in this in problem number 7? 69.4, right? So here our mean is 69.4 and our standard deviation is 2.9. So I'm going to use the same formula right here, guys. The first thing I'm going to do is I'm going to put the 69.4 plus, then I'm going to take the z-score, which we just got to be 1.28, and we're going to multiply it by 2.9. Okay? So guys, just like we were doing on the calculator earlier, what should be our first step? Oh yeah, like, yeah. Let me do that. Okay. Back here. So Isaac's saying, let's be consistent and write it like this, like that, right? Okay, so guys, what's the first thing we should do here? Well, we already found the z-score, right? Remember, the z-score gave us that 1.2 parentheses, right? So we're going to 1.28, guys, good, times what number? Times what number? 2.9, okay. And I'm coming up with 37.12. And then we're going to add what number to it? 69.4. 73.112? 73.112, is that right? Yeah? Okay. That's our height in inches, right? Let's put it this way. If my math lab tells you to round to like 1 decimal place or 2 decimal places, then we'll go ahead and do that. Just because, so like in this case, guys, I didn't end up with like 73 point, a whole bunch of numbers. I'm just going to write them down. But if it does tell me to round, then I definitely want to do whatever rounding it tells me, right? Okay, guys, I want you to look at the next problem here. Part B. It says, what height represents the first quartile? So I want to think about, very good. Do y'all agree that quartile means 25%? Okay, so guys, the first quartile is the same thing as saying the 25th percentile, right? It's the same idea. So guys, think about what we did in the problem A. We know what the area is. We want to find our z-score. So the first thing I'm going to do is we're going to find our z-score for the 25th percentile. Everybody agree we're going to go to inverse norm again? Okay, so we're going to go second bars. We're going to scroll down to inverse norm, hit enter. We're going to type in 0.25. And let's see, are you coming up with a negative 0.67? Okay, so right here, guys, my z-score is a negative 0.67. Was it negative 0.67? Yeah? Fred, no?
Yes.
Oh, yeah, okay.
I'm sorry, if you're going forward, I thought you were going something.
Yeah, remember, with the z-scores, we're always going to go 2, right? The probability should be the 4. Okay, so guys, we're going to do this just like we did earlier. We're going to take 69.4 plus parentheses negative 0.67 times what, 2.9? Okay, so let's go ahead and do that on the calculator. I'm going to go negative 0.67 times 2.9, negative 3.57 so far? Just multiplying those two numbers? No? Did I do something wrong? Let me see. Negative 0.67 times 2.9, negative 19, negative 0.1943? Okay, negative 1.943. And then we're going to add what number to it? 69.4. And are y'all coming up with 67.457? Okay, so again, just like Juan said earlier, right? Guys, I'm not going to do any rounding on my paper until I get to my math lab and it tells me how many to round to, right? Because what I don't want you to do is you look at your calculator and you put something like 67.5 and it tells you to round to 2 decimal places. You would really have to put 67.46, right? So leave what you have here, right? Leave what you have on your calculator on there, and then do the rounding if it asks you to do the rounding, okay? Just because I don't want you to say, oh, look, this is what I did, and why did it not work, and all that kind of good stuff, right? All right, so guys, we're almost done. We got the last 2 problems to do right here, okay? So let's take a look-see, and it says, scores on an exam for an entry-level position at a reputable firm are normally distributed with a mean of 50 and a standard deviation of 10. The firm will only hire applicants with scores in the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired by the firm? Okay, so guys, I want you to think about what we're looking at here, okay? Here are the scores, right? We're saying we're only going to hire people so that when this area here is in the top what percent? Top 10%. As a decimal, everybody agree that's 0.10? Okay. Guys, let me ask you a question. What would this area over here then be? 0.90. Okay, let me ask you a question. Could we find the z-score here? Could we find this z-score if we know that all of this area to the left is 0.90? What would I have to use? But how would I find the z-score though? Second vars, right? Inverse norm, okay, so we're gonna go right here, guys. We're gonna go second vars, and we're gonna go inverse norm, okay? What area am I gonna type in there? 0.9, right? Because remember, doesn't my table, if I'm looking at my chart, I'm looking at that table, doesn't that table always tell me the area of which way? To the left, right? Okay. So I'm going to hit enter, and I'm coming up with what, 1.28? Okay. So my z-score here, guys, is equal to 1.28. Okay. All right. So now what we're going to do, we're going to come back and we're going to see if we can find our test score. Remember, the test score is going to be the x number. So guys, remember how we were doing this before? Wouldn't we take the mean plus the z-score times the standard deviation? Right? That's my formula. Okay. What is our mean in this case? What is the average of the test score? 50. Okay. Plus, I'm going to do parentheses. What did we get for our z-score to be? 1.28. Okay. Times, what was our standard deviation? 10. Okay. And let's see what we come up with. So I want to say, is it 62.8? 62.8, right? Okay. So what that's telling me is the lowest score that somebody can earn would have been what? 62.8, right? Because that's going to give me the top 10%, right? We found the boundary for the 90% this way. Well, we're finding the boundary for the 90% this way. That means it's the same thing as finding the boundary for the 10% over there, right? And so the lowest score somebody could make would be 62.8 and still be hired by that firm, right? And whenever tested is, I don't know what the scaling is. I don't know, having an average of 50 does not sound great to me, but you know, whatevs. All right, so guys, we got one more like this. Let's see if we can figure the same thing out. This problem, guys, we're gonna do exactly the same way. So look what it says. The weight of bags of baby carrots are normally distributed with a mean of 32 ounces and a standard deviation of 0.36 ounces. Bags in the upper 4.5% are too heavy and must be repackaged. What is the most a bag of baby carrots can weigh and not need to be repackaged? Okay, so guys, just like we did earlier, I'm going to draw just a very basic picture. Here's my lump, my lovely lady lumps, right? And let's take a look here, right? We're looking at the upper what percent? Okay, guys, as a decimal, how would I write that number? 0.045, right? Okay, so look what it's telling me, that if we were to come over here, in this area here would be 0.45. Just like we did earlier, guys. What would my area in the red be? Or how would I at least figure that out? We would go 1 minus, right? Okay, so we're going to go 1 minus 0.045, right? Are you coming up with 0.955? 955, like this? Okay. So guys, remember what we want to do. You want to say, okay, do we know what that z-score would be? So again, if we want to find that z-score, we're going to come back here. We're going to type in inverse norm. What is our number going to be? 0.955? Enter. Guys, 1.69 or 1.7? 1.7, right? Okay, so our z-score, 1.70, right? Or 1.7, how you want to write it. And then I'm going to do the same thing that we did earlier. Look, we're going to write x equals mu plus z times sigma. Okay. What is the mean here? 32 ounces, right? Okay. Plus 1, oops, let me write my parentheses. 1.70 times the standard deviation was a 0.36. Okay. So again, guys, on the calculator, the first thing I'm going to type in is what? 1.70 times 0.36. Did you come up with 0.612? Okay, and then we have to add what number to it? 32? Are you coming up with 32.612? There we go. So the most that a bag can weigh is 32.612 ounces. If it weighs more than that, we got to repackage it, right? Right, there we go. Guys, let me ask you a question. How did these two sections seem today? Way better? So for some of us, yes. For some of us, no. Guys, I am going to post the videos up, okay? So